Emily from the Economics Tutoring Center, and today we're going to go over a perfectly competitive market. Now, before I begin, I'd like to remind you that each teacher may like to use a different notation or different strategy when solving these problems, so be careful to check with your teacher before committing to any of these exact notations. Alright, so what I have drawn here on the board already are two graphs. One is the market and one is the firm. And when we go about solving a problem for a perfectly competitive firm, we're going to start with this market. So in a market, we have an equilibrium. We've already covered this. So that's where supply equals demand. And when we find this equilibrium, it gives us a price. We're going to put that right here. And this equilibrium price becomes important because it's in a perfectly competitive firm or in a perfectly competitive market, each firm is a price taker, meaning they do not get to set their own prices. They have to take it as it is given by the market. So if the market gives an equilibrium price here, then the firm has to take this price when they're calculating their output. So we take this price over here, not exactly a straight line, but you get the point. And right here, this becomes our price line or our marginal revenue line. And so as you may remember, marginal revenue equals price, equals that firm's individual demand curve, and that also equals average revenue. So not all of those are necessarily important when you solve the problem. It's just good to understand that we're taking the price from the market and we need to use that price when we're solving for our equilibrium quantity. Now, originally when you're approaching these problems, you may find that there's a few extra curves or lines on this graph, and that's okay for now. You can ignore them. So when we're working in a perfectly competitive firm, all we care about when we're finding our output. So firms produce where marginal revenue equals marginal cost. So we want to find that intersection point. Well, on this graph, they intersect right here at quantity Q. And again, that's at that same price. So our intersection price is going to have that price given by the market, and it's going to have the quantity given where marginal revenue equals marginal cost. So that's how we find our firm's operational quantity. And now we're going to add in some more curves. So it's going to get a little bit more convoluted, but don't worry, we're still working at this quantity. And we're going to start by drawing in our average total cost curve. So I'm going to go ahead and draw in two examples. One where our average total cost would be below our marginal revenue, and one where it would be above. So if it's above, we see that at that quantity, go ahead and drag that all the way up so we have a line representing that quantity. At this quantity, our average total cost curve is above our marginal revenue or our price. And so because of this, we're going to get negative economic profits. All right, so let's try to do this with numbers now. So let's say that the price set in this market was $5. So we take that $5, that's where our marginal revenue is. And again, I picked an arbitrary price based on this market. I'm going to pick a quantity. Let's say this intersects at 100. So if we wanted to find a numerical representation of what our total revenue was, we would take total revenue equals price times quantity. Our price, marginal revenue, was 5. Our quantity was 100. So we get a total revenue equal to 500. Now, if we were to put in a price for our average total cost curve, we note that this is above 5. So let's go ahead and call this 6. Most of the time when you're given these graphs, these numbers will be given to you, so you don't need to worry about picking values. but we notice that this line for average total cost is above this line for marginal revenue. So if we wanted to find total cost, we would multiply average total cost times quantity. Average total cost was where that quantity intersected the average total cost curve, so 6. And that quantity is the same in both of these equations, because we're using the same quantity to find all of these numbers. So 6 times 100 is 600. So you see that our total cost here exceeds our total revenue, and so that's what we call a negative economic profit. All right, so because we have a negative economic profit, we're going to want to determine whether or not the firm should shut down in the short run right now, or if they should remain in business right now, because they're making a negative economic profit. So in the long run, they don't want to stay in the market at all. They're making a negative profit. It's not beneficial. But in the short run, we have these things called fixed costs, and so we need to evaluate it a little bit differently. That means we need to look at one more curve on the graph. So I'm going to draw in something called the average variable cost curve. All right, so this curve that's below average total cost is our average variable cost curve. And the reason that's important is because if our total revenue does not cover our total variable costs, we're going to shut down in the short run. So let's look here to find out whether or not our total revenue covers our variable cost. So here, again, using that same quantity, we meet our average variable cost at a quantity below our marginal revenue. Let's call that 4. So what is our total variable cost? Well, just like how for total cost we took average total cost times quantity, for variable cost, we're going to take average variable cost times quantity. Average variable cost was 4 because that's where 100 met the cost curve. And we're going to multiply that by 100 because, again, we're using that same quantity in all situations. So 4 times 100 is 400. So variable cost equals 400. So we can see that our variable costs were below our total revenue. So our total variable cost, I can go ahead and add a T here for total variable cost. We're lower than our total revenue, and so we're going to stay in business in the short run. However, in the long run, since we were making this negative economic profit, the firms will leave, and we're going to have a decrease in supply in the entire market. All right, so now we're going to do an example on this graph where the average total cost curve is below our marginal revenue line. So I'm going to draw in a new average total cost curve. All right, so remember that we still took this price as given, and we found that quantity for where marginal revenue was equal to marginal cost. So now we're going to try to find out whether or not this firm is making positive or negative economic profits by comparing where our costs are to where our revenue is. So where does this output, 100, intersect our average total cost curve? So dragging this up one last time, and then over to the price, our average total cost is below our marginal revenue. And so let's represent this in equations. Total revenue, price times quantity. We've already done this calculation. I'm just going to do it one more time. Was 5, our marginal revenue from the market, times our quantity, 100, 500. And our total cost was our average total cost. Well, we said that intersected at 4. Times our quantity, remembering that we're still using that same quantity, is 400. So because our total costs were lower than our total revenue, we're actually making a positive economic profit in this situation because we're able to gain more money than we have to pay to make the product. And so in this market, because we have positive economic profits, we're going to have, in the long run, more firms enter the market. And so we're going to have an increase in supply in total because everyone else wants to make a positive profit too. I hope you found this video helpful. If you need any more assistance, feel free to come to the Economics Tutoring Center in the BA building. But otherwise, have a great day.